Hello and welcome to C++ Weekly. I'm your host, Jason Turner. I am available for code reviews, contracting, and on-site training. Primarily what I do is I teach C++, but I also do actually a lot of contracting. And I saw something recently that, I just want to share with you and why it is such a bad idea, basically. So I've got this code here. Now I'm going to start with the bad idea. I haven't disabled the uninitialized variables warning. Well, I'm still getting a warning from the compiler. Well, that's actually really interesting. It seems that Clang is completely overruling me. Let's see if that's true. Ah, there we go, is the order of operations. All right, so I'm going to take I, increment it a couple times, and return it. Now, what value is being returned from main? We don't know. It's in fact unknowable because we started with an uninitialized value. So the compiler actually went through and said, well, you started with an uninitialized value, so I'm just going to throw away all of your work. It doesn't matter what you do here. You started with an uninitialized value. I'm giving you an uninitialized value back. Actually, this is interesting. It's now returning 0 to me. Why? It says XOR EAX, EAX ret, but I'm getting program returned 26, and that's because I am actually executing it with GCC trunk instead of Clang trunk. So GCC just, made up some value. It said 1050 should be the result. It treated this as if it were initialized, but it's not. Turn off optimizations, and yeah, we can see that it's not initializing the value here. It's doing whatever it wants to do. So if you have an uninitialized value, you try to access this value, you are invoking undefined behavior. There is no way around it. This is undefined behavior. And we can see that the compilers do pretty much whatever they want to do. They might return the last value that happened to be in EAX. They might return 0. They might return, 2. GCC is just treating this value as if it were initialized, but it wasn't. Now, to be clear, if this value is up here, then it is actually a default initialized to 0. Statics are initialized to 0. And you might ask, why in the world is a static initialized to 0, but a local value not initialized to 0 in C++? And that is because this operation, depending on context, might actually have a cost to it. It might have to actually write some memory, some value to some memory location, where this, that is declared statically, can actually be initialized to 0 at compile time. And we can see that here, .04. We're saying 4 0 bytes are to be put at the memory location that I am naming I. That's this global name I here. Let's go ahead and change this to J so we can see the change. Here's J. So yeah, local values not initialized in C++. Our compilers really want to warn on this. So if I'm using this value uninitialized, I'm getting this here. That's W uninitialized. And yeah, I've got W error, W conversion, W all, W extra, W pedantic, all these things. Let's turn those off. Well, and now I'm no longer getting a warning at all from GCC. Let's go back to Clang. Clang also no longer giving a warning. Some of these things give warnings regardless of your warning settings, but in this case they don't. So really important that you have your warnings turned on, at least W all. And if you follow me at all, you know that I recommend many, many more warnings than this. So yeah, please make sure that your warnings are enabled. Please, please do not disable uninitialized value warnings. They're there to help you, and they're there for a very good reason. because otherwise the compiler, like we see here, it's just going to throw away work because it knows that if you started with an uninitialized value, it doesn't matter what you do after that, it is going to be garbage. So thanks for watching this episode of C++ Weekly.